Right, so here we have a machine over here, and we see it's a generator here because we have a voltage, a voltmeter measuring the voltage output there. So 10.1 says what type of generator is shown in the diagram above, right? Only AC or DC generator there. So this is an AC generator. It's an AC generator. Why? Because it has slip rings. It has slip rings there. Over there, those are slip rings there. Not a split ring commutator. We have slip rings there. Okay. Now, this is 10.2 actually. 10.2 is looking for a reason. Is because it has slip rings instead of a commutator, instead of a split ring commutator there. So now 10.3 says give one reason why AC voltage is preferred to DC voltage for everyday use. Now first and foremost, AC can be stepped up, and also it can be stepped down. AC can be stepped up and stepped down. And number two is that it can be AC can be transmitted with a low energy loss. It can be transmitted with low energy loss there, with a low loss of energy there. Now 10.4 then says, now sketch an induced EMF time graph for one complete rotation of the coil. So starting from there, it seems there you can see them where we are starting there. We are starting whereby the coil is perpendicular to the field. Is perpendicular to the field. So when the coil is perpendicular to the field, we have we have zero. We start at zero. It means our graph will start at zero there. So we have 0 to maximum to 0, and then going below there in the opposite direction, because it's AC, it changes direction every half a cycle there. So that's the graph that we have there. So here we have induced EMF. We have EMF there in volts, and then here we have time in seconds there. And then it's an AC graph here. If it was a DC graph, then if it was a DC generator, we would have a different graph, a graph that does not show a change in direction, just a fluctuation of the magnitude of the induced EMF, but it would not change the direction of the current every half a cycle like a DC, like an AC would there. So now when you draw the graph, it's always about where do you start? Do you start with maximum or minimum? Do you start at, with maximum or zero? And are we drawing AC or DC? Because the DC graph would look like this and the AC graph would look like this there. Okay. Now we have one over there. It's an AC generator. The reason is because it has slip rings, and then that the advantages of an AC voltage over a DC voltage is that it can be stepped up and stepped down, and then it can be transmitted there with low energy loss, especially over long distances there. So I see it's one reason, or any one of these reasons there. It's one mark there. And then for the graph, two there for the graph, and this is an activity out of 5. Okay.